So today we are still solving systems of equations. So remind me from yesterday, well, no, for you guys it was 2 days ago. Remind me what a system of equations is. What is a system of equations? Okay, good enough, fine. Two or more equations, right? And we look to solve a system of equations. And when we solve a system of equations, because we began solving them graphically, you could describe to me what that solution looks like. What are we looking for when we solve a system of equations? Well, those are going to be the different methods. We haven't even got into the other two. I'm just only, because we began with graphing, you were actually able to see the solution taking place. So I tried to stress to you, say, hey, solution, I want you to associate it with this other word. When you are looking for the solution of a system of equations, in actuality, what are you looking for? What is another word you could use to describe the solution of a system? We spent Monday working on it. Yesterday, I gave you the computers and you worked on the homework. What other word can be used to describe the solution to a system of equations? You worked on word association. It's like, hey, this word means this. Chantal, any idea? Starts with in and ends with intersection. Yeah, you're looking for an intersection. How many equations did I say specifically these systems are going to contain? 2. What does each equation look like on a graph? What does each one look like? Trey? Not a point. Yeah, each one looks like a line, right? So if we draw 2 lines, what are we looking for? We're looking for if and where they intersect. What is the point of intersection? Okay. The only thing is today we're gonna do so algebraically. There's gonna be no pictures. It's like, oh man, yeah, it's like reading a book without the pictures. Boring. Okay. But now the bad thing is about it is that we're not gonna be able to see it. The good thing is that we can be a lot more precise. We can be more exact. Even if 2 lines are going to cross that coordinates that contain a fraction, a decimal, whatever it may be, we're not going to be scared. It'll work out just fine. We'll be able to solve for anything no matter what. Okay. But now there's 2 algebraic methods. And I will tell you that when it comes time for you to take a test, I'm not going to force you to use any one specific method. When you took this last semester, the test, not the entire test, but part of the test said, hey, solve specifically by substitution, solve specifically by elimination. You also had some problems where it was your choice. For me, it's just going to be all your choice. So one of the things we're going to talk about today is when it's best to use each method. So, I know you can see it in front of you. I know I have a limited attention where I can hold on to you guys paying attention. So I'm just instead of going little by little, let's just reveal everything. And what I want to do on this page is just hit the highlights. Let's compare and contrast. Okay, we're going to talk about, look, here's substitution, elimination, and we're going to talk about how they're the same and how they're different. These are both algebraic methods. They're both ways to find an intersection without graphing, without drawing a picture. Okay. The first step in each one, and I know that elimination seems like it's really long. All of this is considered to be the first step. Okay, like all of this is considered to be the first step, but that's just a lot of verbiage. It isn't so much, it's not like you're going to be working for a year. If anything, I would probably say in my experience that more of the children prefer elimination to substitution. But if you know how to use both of them, that's to your advantage. I always give this example. Back at when I first started teaching, right? It was in a different state, and there was a course that was kind of very similar to what you're taking now, which it had like a remediation component of algebra. And when I taught this unit for systems of equations, much like in this class, there was this one student who she would never come to like absent all the time. By the end of the year, probably had like 50, 60 absences of the year. He might in this class, I probably have a few people that would be like more than one person that would be like that. But she was absent a lot, right? But she was actually pretty smart. And what I mean by smart is that when she was here, it did not take her a lot of time to understand what was on the board, right? So the point I'm trying to make is she was here for the lesson on substitution. Okay, instead of doing it all in one day, I had more time to cover things, so I spread it out over like 3 days. She happened to be here for substitution. Then I think it used to take 2 days to do elimination, but she missed both of those. Came back and took a quiz. I don't think it was a test. I think it was a quiz. But like much like on the test I'm gonna give you, I gave the kids the choice. Use whichever one that you want. But when she finally got around to taking that quiz, I think she was even asking for the quiz. But when she finally made it back and took the quiz, the only thing that she had at her disposal was substitution. She had no idea what elimination was. What do you think she got in the quiz? I think it was a 10-question quiz, just to give it a number. Huh? Think you got a 70? Do you think I would go through the whole trouble of making this story if she got a 70? Yeah, she got 100. She got them all right. Got every single one right. Now, I will tell you that she made things very difficult on herself because if all you know is substitution, there are definitely some systems that are, I'm going to say easier, quicker, whatever you want to say, with elimination. She ran into some real nasty fractions because all she knew was substitution. But the point I'm trying to make to you, the point for the whole story is that every system can be solved by substitution. Every system can be solved by elimination. So when we start talking about when it's better to use one or the other, it doesn't mean you have to. If Ferris shows up next week and says, "Oh, you know what? I am protesting substitution. I do not like it. It's too many syllables. I hate substitution. I'm only going to do elimination." He could get every single one right by using elimination properly. If Donnie says, "Well, yeah, I'll show you. Watch. I'm only going to use substitution, and I'm not scared of fractions," he could get every single one right. As far as choosing a method, there is no right or wrong answer. There is a quicker answer. You can say there is a better answer, but there isn't one that's right or wrong. You can use whichever method you want. Okay. So now let's talk about each step. Let's start with the first step. The first step in each method is important because I think that's the one that dictates to you what should be the better option. Sometimes there isn't a better option, but if there is going to be a preferred method, that's where you're going to find it in step one. If I were to give you a choice between doing something the easy way or the hard way, which one would you prefer? Does anybody here prefer doing things the hard way? Donnie? Yeah, Donnie's all about hard way. Okay, so assuming that you, like most people, like things easy, given any task, it doesn't have to be math related, it doesn't even have to be school related. If you are asked to do something, what is the easiest way to get it done? Just do it. That's the easiest way to get it done. Come on. Yeah. Let's be honest. Estudiando. Yeah, let's say whatever. You have to clean up your room. You have to mow the yard. You have to go. You have to go out and find something. Whatever it is, if you're given a task that you have to accomplish, what is the easiest way to get it done? Ask your brother. Well, that's kind of where I'm headed. You don't need to have a brother. Just throw it on the bed. Well, that was one. One of them was clean the room, yeah, but there was other. It doesn't necessarily pertain to cleaning a room. It could be anything. When you are asked to do something, what is the easiest way usually to go about getting that? Say you're sick. It's amazing how you guys are telling me things that you think I want to hear instead of just telling me what is the honest truth. Cheat? Well, okay. I mean, yeah. I guess you could go that route when you are cheating. So you are partaking in what I'm trying to get at. Have somebody else do it for you. Normally, where the easiest way to get something done is have somebody else do it for you. You either have your husband or get somebody to do it for you. Wash the car, things like that. Take it to a car wash. Go out and buy something. Nah, forget it. Get it delivered. Okay, have somebody go and do it for you. So the point I'm trying to make with step one is that is gonna, at least for me, the approach I'm gonna take is I'm gonna go with the method where step one is done for you. You're not always gonna have a step one done for you, but if you do, then we would go that way. Look at step one for substitution. What does step one for substitution say? Solve for one variable in one of the equations. How many equations did I say we were gonna have? Two. And if you remember anything from 2 days ago when we did graphing, how many variables did each equation have? Also two x and y. So if you have two equations and two variables, how many variables do you have in total? You have four. If you happen to have just one of those variables already by itself, already isolated, I'm probably going to go the substitution route. Not because I have to. I already established with the whole story about the girl with the quiz. Not because I have to, just because it'll hopefully be quicker. If I have one variable already by itself, I'll go with substitution. That's the way I'm going to demonstrate. I know elimination seems really, 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 really long, okay? But the key to focus on here, I tried to underline it for you. And since you're actively participating and writing down on stuff on your notes, standard form. We should already know what standard form is. If both equations are in standard form, that's going to be enough for me to want to go through elimination. Now, as you can tell from the notes, there's excuse me, there's more to step one than just having equations in standard form, but that's going to be enough for me to go the elimination route. Those are the two things I'm looking for. If none of those apply, if I don't have a variable by itself, if I don't have both equations in standard form, it's possible, then you would just pick one. Pick whether you prefer to solve for a variable on your own. Pick whether you prefer to put both equations in standard form. It's your pick. That's the approach I'm going to take. Okay. The second step is where each process gets its name. What is the second step for substitution? To substitute, sure. That's why it's in capital and bold and an underline. What's the second step for elimination? To eliminate, but just as important as knowing that it's to eliminate, understand that you don't have an eliminate button on the calculator. I guess you don't have a substitute button either, but just know that when I ask you what are you doing when you're eliminating, you're adding. We're doing elimination by addition. There is such a thing as elimination by subtraction, but in my experience, too many people make mistakes with signs. So I've stuck to just only teaching it through addition. You're less likely to make a mistake. Even though both processes have a different name, they both accomplish the same thing. If you want to try to figure out what they accomplish, let's focus on what's on the board right now, which is eliminate, right? What do you think you're eliminating when you are like when it says eliminate? What do you think you're eliminating? The numbers? No. Well, don't say the variable, because how many variables are there? Two. So what do you think you're going to be eliminating? If there's two variables, what do you think you're going to be eliminating? One of the variables, sure. You're going to be eliminating one. It does not matter with that two line. It does not matter. Okay. So in elimination, you are able to get rid of one of those variables by using addition. That's what I'll show you. Now, a bunch of other things have to be true first, but when you get around to eliminating, it's going to be through addition. Even though in substitution, we call this, we're going to substitute we're going to accomplish the same thing by substituting. What you should be able to see after you substitute, after step 2 on either process, you should go down from 2 variables to 1. If you still see x's and y's after step 2, you're doing something wrong. Okay. Step 3. How is step 3 important? Well, really, steps 3, 4, and 5 I could lump together, because if you look at both processes, even if you can't see them on my board, look at your paper. How do steps 3, 4, and 5 compare on each of the processes? How do they compare? They're the same. They're the same. So once you get down to one variable, you're going to do the exact same thing, which is solve, substitute, solve. Okay. I'm not even going to really talk about step 4 and step 5, because that's you're gonna just it's gonna funnel you right into what you need to get to. But I will talk about step 3, because step 3 has a little bit more significance. Do you remember when we graphed that before we even put a graph on the paper, we were able to tell what type of solution? What were the 3 types of solutions that a system could have? No solution, one solution, or infinite solution. That just because we're not graphing doesn't mean that those don't apply. It's the same types of solutions. We're going to have either infinite solutions, no solution, or one solution. That same thing applies. And now with graphing, what we were able to look at was the slope and the y-intercept. Here, we're going to look at step 3. If you are able to complete step 3, you have to be able to do 4 and 5, which means you have to have one solution. If you cannot complete step 3, that's when you have either no solution or all infinite solutions. And then I can tell I'm already losing you, so we'll talk about later as to when it's infinite and when it's not. Right, Ferris? Are you dreaming of Joanna? Are you dreaming of Joanna? No? All right, so let's get to the examples. Here is a system of equations. I have 2 linear equations. But instead of graphing them and seeing where they cross, I'm going to solve by one of the algebraic methods. I can use whichever one I want. So let's talk about which one we're going to use. Not because we have to, but because we want to. What would be the ideal method to use? I like substitution here. Again, not because I have to, but why do I like substitution? Very good. God is on fire today. Take that, Ferris. I have 1, 2, 3, 4 variables. Jade, it does not matter which one. And we're used to having y by itself. It doesn't necessarily have to be a y. But in this case, I do have a variable that's already by itself. So I'm going to use substitution. When I see a variable by itself, it only has to be one variable and one equation. I'm going to use substitution. If I were to label, like if I imagine like I had a little stamp and I could label when each step was done, at this point I could already stamp this was step 1 because step 1 is done. And that's nice. I like things being done for me. I didn't have to do anything and step 1 is done, assuming that I use substitution. Question? I see a hand up? Yeah. Well, okay, so now here comes step 2. What does step 2 say to do in substitution? I like to just draw this line so I know what my original equations are. We're going to do what? Substitute. What did I tell you is the goal that we're trying to accomplish by substitution? How is that second step significant? By the time I'm able to now stamp this with step 2, what should be true? If you listen to what I said on the first page, even though it was really, really boring. Really, really, really boring. Nah, not one equation. Even though actually, I guess technically that's true, but more. I'm going to be down to one variable. I should be down to one variable. So let's see. Here's the logic behind it, right? And I'm going to help you draw a quick picture. Remember how 2 days ago we were looking for the intersection? Well, if 2 lines indeed do intersect at one point, at that one point, both equations share the same x and same y. If we were to get that logic and apply it here, I am looking, see, this is a statement of equality. The first equation says that y is the same as 3x. The bottom equation says that x plus 2y is the same as negative 21. That means the same. But in this case, I am also, in addition to that, I am looking for any place where this x is the same as that x, and where this y is the same as that y. Because that would have to be true if they intersect. They're the same as each other. So I can use that equality to my advantage and say, all right, well, since the y on top is isolated, and that y on top is equal to 3x, but I want the top y to be the same as the bottom y, what can I say that the bottom y is also equal to? We already said that. We already said the top y. What is the bottom y going to also be equal to? To 3x. So what I'm going to do now is write that other equation. I'm not going to write the top one where the y is by itself. I'm going to write the other one. I'm going to write x plus 2. Oh, I got to the y. I'm not going to write a y. What am I going to write instead? I'm going to write 3x instead of y equals negative 21. I wrote the entire second equation exactly the same. Just instead of a y, I wrote a 3x. Now, what did that accomplish? What do you see below the black line that you do not see anywhere above? Not only one equation, but more importantly, no. Well, yes, there's two x's there, but the fact that there's one variable. There's only x's. There's no y's. Do you see any more y's? No. So I can now stamp this. Step 2 is done. Not that you have to do this. I'm just trying to help you connect the first page to the examples that come afterwards. What does the third step say to do? Now I can solve. Now that I'm down to one variable, I can solve for that one variable by using my equation solving skills. 2 times 3x is 6x. Combine like terms like they do in the hood. And now I'm able to solve and say that x is negative 3. Question? Well, now you know it's right. And not only is it right, okay, because I am able to complete step 3, I now have a variable solved for. I know that x has to be negative 3. If I'm able to solve for x, that means I have to be able to solve for y. And if there is an x and there is a y, that means there has to be one solution. Long story short, if you're able to complete step 3, you have to have one solution. The only way you can have no solution or infinite solutions if you're not able to solve. Basically, instead of having one variable left, you would go down to no variables left. All the variables would cancel, not just one of them. Okay, but yes. Look at all these examples I have left. I'm pretty sure we're going to get to elimination. We got 2 days to cover this. Unlike graphing, we have 2 days to cover this. Okay. What does step 4 say to do? Substitute. Okay. Now that I have the value of one variable, I can plug it in, but I can plug it into whatever equation I want. So this is more of an opinion, but it's an opinion that's based on years of observation and it's kind of based on fact. I feel like more kids start to prefer elimination. And I think the reason for that is because assuming that something is not custom made for substitution, you would have to be the one isolating the variable. Okay, if it's not done for you, and sometimes that process of isolating can cause fractions. I told you about that girl that got the 100 on her paper. Yeah, she got 100 on paper, but I mean, she was dealing with some nasty, 117 over 24, like a real ugly looking, improper fractions. But that doesn't mean you're gonna get something wrong. It just means you might have to encounter that. Now, what a lot of people neglect, though, is that the good thing about substitution is at the end. Yeah, sometimes it might be harder at the beginning, but substitution pays off at the end because if I have x, what am I looking for? Y. And the good thing is, with substitution, you're always going to have that second variable already isolated. It's going to be nice and pretty waiting for you. You can use, if I wanted to use the bottom equation, I could. I could plug in the -3 for x on the bottom one if I wanted to. But this would be much easier if I just said y is equal to 3 times -3, which gives me -9. So all the children rejoice. We already knew we were going to have one solution. That one solution. Because we're not graphing, the variables are not going to always say x and y now. You might get a's and b's. You might get c's and d's. You might get m's and n's because we're not graphing. So when you write an ordered pair, your answer choices in multiple choice, Chris, are going to be in the form of ordered pairs. The order in ordered pairs means alphabetical order. So keep that in mind because here, what happens since now any variable could be by itself first, you might end up solving for y first, and then you solve for x. But don't write -9, -3, put it in alphabetical order. -3, -9. Fax machine. Yeah.
If we put it like the wrong way, then you take
Well, remember, I'm giving you everything in multiple choice. So yes, if you put it the wrong way, you're gonna get it wrong. If you have the work in it, you have that's the trade-off with multiple choice. Is in exchange for giving you a bunch of possible answers and stuff like that, yeah, you have to know that it's x comma y. If it's a's and b's, the a comes first and then the b. Don, hey, this problem goes out to you, buddy. Huh? Well, yeah, not because I have to, but since I'm giving you the option of using whichever method you want, I would like the one where I do the least amount of work. And if I look at both of these, are any variables isolated here? No. But with that being said, it wouldn't be that hard to isolate this first x here on top. It'd be pretty quick. I could just subtract 5y and bam. So if you fall in love with substitution, I'm not saying that you can't do substitution here. But the nice thing about this is, what form are both equations in? Standard. What did I suggest to you for standard? Elimination. So in this one, I'm going to go ahead and do elimination. But unlike the last one with substitution, all of step one is not done. These aren't all necessarily things that you have to do, but they're all considerations that need to be made. Okay? Now, in this case, part A of step one is done because of the standard form. And again, that is enough for me to say, hey, you know what, let's just do elimination. But there's another part that's just as important, and that's that we need to have matching coefficients. What's a coefficient? The number in front of the variable has to match, but at least we're not going to care too much about sign, at least for this part. By the time we're done, we have to, but we need to have the same number in front. And then eventually, we want to make sure that the signs we need the signs to be different. So like we want one x to have a positive 3 in front, and then the other x to have a -3 in front. If we're going to get rid of the y's first, one y has to have a positive 5, and one y has to have a -5. And if that isn't the case, then what this last part does is it shows you how to make it the same by using the least common multiple. I'm not going to make you read everything because then everybody's going to fall asleep like Ferris is doing, but I'm just going to demonstrate it for you. If you think of these as being columns, and we want the x's lined up above each other and the y's lined up above each other, do any of do either the x's or y's have matching coefficients currently? No, so we're going to have to make them match. Tazon, I think I remember yesterday showing me some problems from that challenge thing that and they didn't match up. This is how we're going to make them match. You can make whichever variable you want match. It doesn't matter. Just one of them has to match because that's how we're going to get rid of them. Let's look at the x's first. What does the x on top have in front of it? 1. A 1. What does the x on the bottom have in front of it? So we're going to use least common multiple. What is the least common multiple of 1 and 3? It is 3. If I count by ones, least common multiple means count by that number. 1, 2, 3, 4, 5, 6, 7, 8, 9. Count by threes, because that's the other number. 3, 6, 9, 12, 15, so on and so forth. What is the smallest number they have in common? 3. So 3 is the least common multiple. So if the x's are going to match, if we're going to choose x's, we're going to make them match at the number 3. We're going to turn them both into 3's. But you also have the option of making the y's match. Okay, we're not going to worry about signs at the very beginning, so don't worry about the fact that it's positive or negative. What's in front of the y? The top y, sorry. A 5. What's in front of the bottom y? A 2. What is the least common multiple of 5 and 2? It is 10. If we're going to make the y's match, they're going to match at 10. Now, don't overthink this. Don't be like, oh, but which one? I don't know which one to make. Just pick one. I can tell you what the benefits are. See, the nice thing about making the x's match is that I'm only going to have to multiply one of the equations because the bottom one already has a 3. We just said that we're going to make them match at 3. The bad thing about the x's is that the signs are the same. So we're going to have to make them different because we want to end up with different signs. The good thing about the y's is that the y's already have different signs. The bad news is that we're going to have to multiply both equations because we need to get them to a 10, and neither of them are currently a 10. Hang in there, Ashley. I'm going to hand out t-shirts afterwards. I'm going to say, I survived Mr. Romero's class, 3/13/19. Trayshawn, which one I'll let you pick. Which one do you want to get rid of, x's or y's? You want to get rid of the y's? Okay. So if we get rid of the y's, if, I didn't say we have to, if we choose to get rid of the y's, what number did we say was going to be the LCM? 10. At 10. So 5 times what gives you 10? 2. So everything on top needs to get multiplied by 2. Does anybody remember this from first semester? Kind of, sort of, maybe, but not really. Okay, how about on the bottom? What 2 times what gives you 10? Because I got to turn that 2 into a 10. 5. Now what people forget is that everything has to be multiplied by 5, including the other side of the equal sign. So now I can rewrite my system and say 2x plus 10y is equal to -6. I can then say 15x minus 10y is equal to 40. And if I was labeling my steps like I did with the substitution, now is when step 1 would finally be done. Because I have matching coefficients with different signs. Both of the y's have 10s in front. One is positive and one is negative. How are we going to eliminate? This is important. We are setting everything up for elimination by y. Okay, fine. Yes, you are going to cross out the y, but how? Not subtraction. I actually put even a circle around it. Still circled on the first page. This is called elimination by addition. That's important because, yeah, Chantel, everybody remembers that elimination, I'm going to cross them out. Okay, cool. But what am I supposed to do with the other columns? Yeah, well, that's the key there. It's addition, elimination by addition. So if we're adding the y's, and that's what's allowing us to cancel them out, you have to add everywhere else. 15 and 2 is 17x. Drop the equal sign, -6, and 40 is 34. That is step 2. But what do you mean? Why step 2? Well, because I finished eliminating. And what feature did I tell you would stand out if you do step 2 properly, regardless of the method? What should be true after you're done with step 2, whether you're doing substitution or elimination? One variable. Everything above this line had 2 variables. Now I'm down to 1 variable. So I can do as the Romans did and solve. Because I now know that x is equal to 2, step 3 is done. How is step 3 significant? Because I was able to complete step 3, what does that mean? Meaning what? Meaning what? Meaning what? Meaning what? Interpret this for me. Since I'm able to finish step 3, I know that I'm going to have one solution. I told you step 3 tells you the type of solution. If I'm able to finish step 3, I know I'm going to have one solution. If I can't finish step 3 because now all the variables disappear, it would either be no solution or infinite. We haven't got one of those yet, but we will. Okay? Then yes, you are right. You can substitute. Some people prefer elimination because wow, and even though this one seems like it's hard, sometimes it's nice and they give you all the matching coefficients and it takes 2 seconds. You're like, whoa, this is the easiest thing ever. But now this second substitution isn't always as clear cut. Well, I'm not even say clear cut. It's not as efficient as with substitution because there's no variables that are by. I need the y, but I don't see a y by itself. You can pick any equation you want anywhere on the page. I would assume most of you would probably pick that one because even though the x is not by itself, at least it doesn't have a number in front. So I could just write 2 plus 5y is equal to what? To 3. Instead of x, you write 2 plus 5y equals -3. Something else I didn't point out before, but I should probably point out now. Anytime you see the word substitute, we already saw it before in step 2, but substitute also belongs in both methods at step 4. You should only see one variable. Every time you see substitute, there should only be one variable. I just finished substituting. How many variables do I have here? Just one. Now I only have the y's. Step 4 is done. Let's solve. -2 minus 2. 5y is equal to -5 divided by 5. Y is equal to -1. So without drawing a picture, I now know that these two lines are going to cross. Where are they going to cross at? At +2, comma -1. If you're not sure what the order is, it's alphabetical order. 2, -1. Mucho bueno. Okay. Ooh. Ah. Okay, so Donnie is requesting substitution. I would agree with him. I'm going to do substitution on this one. I'm going to just do we're going to do all of these together today, and then tomorrow, that is an extension, we'll go back to, okay, I'll let you work it out, and then you tell me what your answer is.
Tomorrow we're going to have 3 hours left.
No, we're not going to. You will not have another 3-hour class with me. You will have other 3-hour classes. No, it'll be not next week, the week after. The week before spring break. It wouldn't make sense to have a 3-hour class during spring break. But the week before spring break, on that Monday, you have a 3-hour class at the beginning with a second period. You don't come to me at all. And then you have a 3-hour, and the next day too, and Tuesday. I don't see you Monday or Tuesday. The Tuesday, you have a 3-hour class with third period.
What do you mean? 3, then 3 for 3?
Yeah, we'll worry about that when we get there. You'll probably forget by the time we get there anyway. So let's just finish this one. Donnie said substitution. The reason why Donnie said substitution is because we had a variable by itself. So bam, look, step 1 is done. I don't expect you to label your steps, but I'm just letting you know. So you can follow along and feel educated. Now, because I have that variable by itself, that's what allows me to substitute. If the bottom y is the same as 3x plus 2, but I want the bottom y to be the same as the top y, I can write the top equation. You got 10 minutes left here. I can write the top equation, but when it gets time to write the y, I'm not going to write y, I'm going to write 3x plus 2. All I did was I wrote this top equation up here Just instead of the y, I wrote 3x plus 2. What did that accomplish? What do I have now that I didn't have before? One variable. I have successfully got rid of one of the variables. So now step 2 is done. What does step 3 say to do? Let's solve for that one variable. Okay, if I'm able to do so, if I'm able to find a number for x, that means I have to be able to find y. If I can't find the number for x, that's because one of the ugly things is either no solution or infinite solution. Uh-oh, SpaghettiOs. Once I distribute, caca. I was trying to solve for x. Today is a sad day. Let's lower our heads as a show of respect. The x's are no longer with us. Oh, you got a different paper even though I gave you paper? Rebel. Mr. Romero, I don't need you or your paper. In the past, when we've had variables cancel out, what have you been taught to do? Very good. So look, what do we know so far? So far we know we cannot have one solution. There was no way to solve for x. I was not able to isolate them. They're all gone. But I'm going to do, based on previous knowledge, I'm going to drop down the leftovers. When I cannot solve, I know that there cannot be one solution. So my only possibilities are infinite solutions or no solution. Because the leftovers are the same, what do you think we're going to have? Yep, this is going to be actually infinite solutions. Because the leftovers are the same. Donnie is uninspired today. Call him Butter, because he's on a roll. Jada liked that one. Any questions there? All right, last one for today. No, but I don't want to go to school. Huh? Okay, elimination sounds good. Now, because I have to look, if I really wanted to make an issue, I'd say, but I love substitution. I want to marry it one day. Well, then look, I would probably try to solve for either one of those. Those are not that hard to solve for. But we like things easy and done for us, so we're going to go with elimination. But is all of step 1 for elimination done for us? No, because we don't have matching coefficients with different signs. We can either make the x's match or the y's match. Donnie, since you've been doing so great today, I'll let you decide. You want to make the x's match or the y's match? You want to make the y's match. Okay, so right now in front of the first y, I have a 2. In front of the second y, I have a 1. What is the least common multiple of 2 and 1? 2. Because the top y already has a 2, I do not have to touch the top equation. The top equation can stay exactly the same because it already has what I need. But I need to make the bottom equation have a 2. 1 times what gives you 2? 2. But see, now the thing is, if I only multiply by 2, yeah, that's gonna fix the number. It's not gonna fix the sign. I need to have different signs. So the way I can do that, I'm gonna multiply by a -2. So that gives me -2x minus 2y is equal to 4. No, negative times negative is positive. And look, here comes Chantal with her crossing out. Yep. So the y's that we were going for, they have different signs, same coefficients. So if I were to stamp it, step 1 is done. But SpaghettiOs, yeah, when I go to add, because it's elimination by addition, it happens to be that the x's cancel out too. Well, hold on. Well, because everything is gone on the left side, what actually is left on the left side? 0. Equal, what is 8 plus 4? 12. You still have to add. 8 plus 4 is 12. Is 0 equal to 12? No. Yeah, we were able to finish step 2. We were able to get rid of a variable, but oops, we actually got rid of both variables. And because what was left over is not, we already know we can't have one solution, but because what's left over is not the same, now we have no solution. Yes? Yeah, you want me to do a substitution? Do a quick substitution, all right. Did everybody have this written down? Just show you what it looks like substitution. If you don't have it written down, you can go back and catch it on the replay. Okay, so if I were to do substitution though, I can't just start off from here. I'd have to, which variable do you want to solve for? The bottom x or the bottom y? This is the easiest one. The bottom y. So I'm going to go minus x. So that would give me y is equal to negative x minus 2. So I would get this and plug it in for the y. That's what y is equal to. Right? So now I would write then, I like to draw these lines just so that I don't get confused. 2x plus 2, but no y, just negative x minus 2 is equal to 8. So 2x minus, I see what you did there. All the variables canceled. Is negative 4 equal to 8? No. So we still have no solution. Well, it's not necessarily you have to get the same numbers. It's just a matter of do all the variables cancel out. I've shown you that all the variables cancel out no matter which way you do it. So that gets rid of one solution. And then even if the numbers themselves are not the same, like, let me rephrase it. Even if these two numbers are not the same as the two numbers I got from elimination, what matters is are they the same as each other? And if they're not the same, it's no solution. If they are the same, it's infinite solutions. So bring this packet back tomorrow because we're gonna continue on it, and then Friday you got lucky, no quiz. But we'll just continue to work on that assignment.